So today we're going to be talking about section 8.1, which is going to introduce us to hypothesis testing, which is actually the area of statistics that we will be studying for the rest of the semester in this class. So hypothesis testing is a major part of statistics because it enables researchers to answer many types of questions. For example, a scientist might want to know whether there's evidence of global warming, or a physician might want to know whether a new medication will lower a person's blood pressure. Or, as in my case, an educator might want to know whether a new teaching technique, such as teaching online, is better or worse than the traditional face-to-face teaching method. And I can actually guarantee that I will be running some of my own hypothesis tests at the very end of the semester to investigate questions like that. Okay, so let's get down some vocabulary involved in hypothesis testing. So first off, a hypothesis test is a decision-making process for evaluating claims about a population. And a statistical hypothesis is a claim or conjecture about a population parameter, and the claim may or may not be true. Now, every hypothesis test will involve two hypotheses. The first one is called the null hypothesis, and the symbol that our textbook uses for that is H naught. Okay, you read that as H naught, or you might hear me say it as H sub 0. So it's just a capital H with like a 0 as the subscript. Okay, so the null hypothesis, what this states is that there is no difference between a parameter and a specific value. The second hypothesis is called the alternative hypothesis, and the symbol for that is H sub 1, or you can just read that as the alternative hypothesis. And that states that there is a difference between a parameter and a specific value. Okay, so basically when you're setting these two hypotheses up, you pretty much have three options for how this can go. Okay, and these are listed in this table here. So let's just kind of analyze the table a little bit. So you'll notice that regardless of which test that you have, the null hypothesis H naught is always going to have an equal sign. Okay, and I'm going to go ahead and make a note of that. So H naught, your null hypothesis, always has the equal sign. Now I'm using mu, which is our population mean, because that's the first hypothesis that we're going to be learning about in the next section. Throughout this chapter and our other chapters, we'll change mu just depending on what we're testing, but I'm just going to use mean for right now because that's going to be the first one that we'll learn about. Okay, so for H naught, it's always going to be that your population mean mu is equal to some number, which we're just representing by a K here. Okay, now the type of test it is depends on what sign is in the alternative hypothesis. So for a two-tailed test, you're going to see a not equal to sign in the alternative. For a right-tailed test, you're going to see a greater than sign in the alternative. And then for a left-tailed test, you're going to see a less than sign in the alternative. Okay, and for every hypothesis test, one of those hypotheses is going to be the claim that we're basically testing. Okay, and the claim can be stated in either the null hypothesis or the alternative hypothesis. So let's move on to example 1. And for each one of these conjectures or claims, we're going to practice stating what the null and alternative hypotheses are, and we'll clarify which one of them is the actual claim. Okay, so part A says that a researcher thinks that if expectant mothers use vitamin pills, the birth weight of the babies will increase. The average birth weight of the population is 8.6 pounds. Okay, so for H naught, our null hypothesis, we're going to let the mean, mu, be equal to the number that's basically in the question. So it says the average birth weight of the population is 8.6 pounds. So we'll let the population mean mu be equal to 8.6. Our alternative hypothesis then, what you want to do is just kind of read the question and look for what it's actually saying. So a researcher thinks that if expectant mothers take vitamin pills, then the birth weight of the babies will increase. Okay, so that researcher thinks that the birth weight will be more than 8.6 pounds if they take those vitamin pills. So in the alternative hypothesis, I'm going to let mu be greater than 8.6. Okay, and that part I'm going to label as the claim. So in all of these questions, for all of hypothesis testing, when we state our two hypotheses, you are going to label which one of those is the actual claim. Okay, that is a very important part that you can't leave out. Okay, so the claim there is what the researcher thinks. And then since the alternative hypothesis has a greater than sign, I'm just going to go ahead and label this as a right-tailed test. Normally you don't have to actually label that, but just for practice, just so we kind of understand what type of test we're talking about, I'm going to do that on these ones. Okay, part B says an engineer hypothesizes that the mean number of defects can be decreased in a manufacturing process of USB drives by using robots instead of humans for certain tasks. The mean number of defective drives per 1,000 is 18. Okay, so I'm going to start out with my null hypothesis. So this is going to be the one where I have mu equals some number. So in the question, it says that the mean number of defective drives is 18. So I'll let that be equal to 18. And then for the alternative, I'm going to have mu is something compared to 18. Okay, so let's read it again. The engineer thinks that the mean can be decreased. Okay, so they think that the mean is actually going to be less than 18. So I'll put less than 18 in the alternative. I'll label that one as the claim. Since the alternative has a less than sign, this is what we call a left-tailed test. And both right-tailed and left-tailed tests are also referred to as one-tailed tests. Just FYI on that. Okay, part C says a psychologist feels that playing soft music during a test will change the results of the test. The psychologist is not sure whether the grades will be higher or lower. In the past, the mean of the scores was 73. Okay, so for H naught, I'm going to put that mu is equal to 73. And then for H1, if I kind of, read the context of the question again, it says that a psychologist feels that there will be a change, and then it kind of clarifies it a little more and says they're not sure whether the grades are going to be higher or lower. Okay, so in this case, I'm just going to use a not equal to sign and then put the 73 in the alternative hypothesis. So since it's not clear about whether they think, the test scores are going to go up or down, we're just going to use a not equal to sign. So if it ever just says like they think that there's going to be some sort of difference and it's not clear which direction they think, then you just put a not equal to sign. Okay, so the alternative there is the claim. That's what the psychologist feels or thinks. And this is an example of a two-tailed test. So if you have a not equal to sign in your alternative, that's a two-tailed test. And then let's look at part D here. So this is kind of the interesting one. It says the average age of first-year medical school students is at least 27 years. Okay, so I know that no matter what, H naught has to be the one with the equal sign. So I'm going to put mu equals 27. Now, here's the interesting part. So for H1, if I kind of read this again, it says that the average year is at least 27. Now, algebraically, at least would translate to a greater than or equal to sign. Well, that's not one of our possibilities. Okay, so your alternative has to be either a strictly greater than sign, a strictly less than sign, or a not equal to sign. I can't put greater than or equal to in the alternative. Otherwise, then your hypotheses kind of overlap with each other. So what you have to do in this case is we're actually going to use the opposite sign. So instead of greater than or equal to, I'm going to put a less than sign. And then I'll put the 27 in my alternative. Okay, so at least does mean greater than or equal to, but I'm not allowed to use a greater than or equal to sign. So I'm actually going to use the opposite, which is a less than sign. And then, since now the null hypothesis has the equal to part, that's the one that's the claim. Okay, so since the equal to part is shared with the at least, that's the one that you let be the claim, and then the alternative is pretty much the opposite of what you're trying to test. Okay, so I know that's kind of the confusing one, so if you want to just make a note for yourself, if you see the words, at least in your claim or the problem, then you're going to let H1, your alternative, be a less than sign. And if you see the opposite, so if basically it says at most, then you're going to let your alternative hypothesis have a greater than sign. So those are the only two tricky ones. Normally they're very straightforward. You just have to watch out for those ones where it's like at least or at most, because they involve equals. So really then you let the null be the claim, and then you put the opposite sign in the alternative.